But what does all this stuff to do with unit circles and points on the unit circle? What has that got to do with trigonometry? Because we're in the trigonometry unit and we haven't had any trigonometry yet. So let's now bring in trigonometry. How does it relate? So consider some point on the unit circle, and we'll stick to the first quadrant for now, which I'm going to call P, with coordinates x, y. We can draw a right angled triangle going to P with x and y, and this length here being 1 because it's a unit circle. And this angle we're going to call theta. But the definition of cos theta is the adjacent over the hypotenuse. So in this case, the adjacent is x and the hypotenuse is 1, which simplifies to just x. Well, what this means is that the x coordinate is equal to cos theta, or vice versa. Cos theta tells us the x coordinate of the point. So if we know the angle, we work out cos of theta, that's going to tell us the x coordinate of that point. In a very similar way, sine theta is equal to the opposite, which is y, over the hypotenuse, which just simplifies to y. So sine theta tells us the y coordinate of the point if we know the angle theta. What that means in general is that any point on the unit circle, if we know the angle theta, has coordinates cos theta, sine theta. We can also define tan in this way because tan is equal to the opposite over the adjacent, which is y over x. But think about what that's telling us. Y is how much it goes up by, x is how much it goes across by. So tan theta is telling us the gradient of that radius that connects the center to the point P. So this is how sine and cosine and tan are connected to the unit circle and the angle that defines that particular point. The coordinates of any point on the unit circle are given by cos theta for x and sine theta for y, and tan theta tells us the gradient of the line connecting the radius to that point. We can use these results not just to find the coordinates if we know the angle, but to do so many more important things with trigonometry.